Thank you for coming, everybody, to this talk in particular. I recognize you all have a choice of which carrier you fly with these days, and I'm very happy to see so many people here. My name's Rob Smallshire. I work for and part own a software consultancy based in Norway, and I'm going to talk to you today about architecture in the age of Agile. I've been working professionally as a software architect for a good few years now, and I've worked in Agile teams in a variety of capacities. I've worked as a developer in Agile teams. I've worked as even a product owner in Agile teams, so I've sat on perhaps what you think of the other side of the fence. The only thing I haven't done, and I'm not ashamed to say this, is ever be a Scrum Master, especially a certified one. So I have perhaps an interesting perspective on how these teams work from lots of different angles and how architecture does or does not relate to Agile. So can you guys all see this at the back? So just a little bit of my personal history. We have 90 minutes here, so I have time to explain a little bit about who I am. I am from not so far from here in the English West Midlands. And throughout my career, I have moved monotonically north with respect to latitude of the Earth. I've pitched up at 60 North, which is where I live now in Oslo in Norway, where we own a company of the same name. And throughout my career, I have worked mostly for product companies rather than kind of line of business enterprise consulting companies. And so I think perhaps much of what you'll hear me say today is colored by those experiences, because I think working in product companies is perhaps quite a different experience from working in line of business development. You'll have to excuse me, I'm going to keep turning around to look at my own slides because this thing is not working. So, architecture and Agile. An odd couple. Both perhaps very dedicated in their way to their own cause, perhaps even zealous or even religious about the way they go about performing software development. And we hope that Agile and architecture can collaborate and work together, and it's all harmonious in our working environments. But we also know that this isn't always the case. All of us are aware of the fact that Agile has perhaps set out to not deliberately cause damage, but to certainly reject certain aspects of software architecture. But perhaps, just perhaps, there's the opportunity for something more harmonious to emerge between these two opposing camps, as we perhaps think of it sometimes. And perhaps even something more than that might emerge if we approach these things the right way. But who knows what will happen ultimately the morning after this great congress of these two camps, these two worlds of how to approach software development. Will it have a happy ending, or will there be regrets? But you're here for 90 minutes, not 5. So what I'm going to talk about today is whether architecture and Agile are strange bedfellows or can even be friends with benefits. And then we're going to move on and look at perhaps the role of software architecture in the sustainability of software over the long term, and why that sustainability is important. And particularly there, you should think about my own background in product companies, where sustainability is important for the very life of the company, not just the success or failure of a project. And then I'm going to finish by looking at the role of architecture in scaling Agile. Agile has been a great success in smaller teams, I think, or small teams. In fact, Agile almost requires small teams. But there's a lot of open questions, I think, about how we scale Agile. And some solutions have been put forward to that. I'm going to propose my own solution to that. And I don't want you guys to sit here and be quiet for 90 minutes. I'm going to ask you to interact now. So every software architecture talk ever, and this talk is no exception, sets out to establish a definition of what architecture even means, right? Or what do architects do? And in fact, a very large proportion of software architecture talks I go to have this section at the beginning, or in fact devote the entire talk to the topic. It's a very important question. So I would like you guys to shout out just some words, some verbs, some nouns, which correspond to what you think these architecture and agile things correspond to. And if people don't volunteer, I'm going to pick people, right? So it's easier to volunteer than be picked every time. And we'll just do architecture on this side, because everyone here has been involved in projects that have involved some architecture. Whether it was accidental or deliberate is perhaps a different question. And on this side of the room, I'm sure you've all had some exposure to agile projects. So just some kind of words from this side of the room, please, on what you think architecture is about, or what it involves, what kind of activities, what are the nouns in there? Decision-making. Sorry? Solutions. Agile. Chaos. You, sir, need to move to the other side of the room. Change, right? More words? Iteration. Was that at the front? Sorry? Iterative, yeah. Flexibility. Was that on the architecture side or the agile side? Agile, right? Okay, a few more. Expensive to change. That's an architecture thing, okay? Speed. Okay, velocity is another word we use for that, right? So, sorry? Responsive, right. So this is a good game. And it's interesting to see how many words come up on both sides of the room, which so far is none whatsoever have been proposed by both sides of the room. But let's just, look at the dictionary definitions of what these things mean. So architecture is the art or science, and we can argue about how much is science and how much is art, of designing and constructing things. And the word design didn't come up from the architecture side of the room, which is interesting in itself. It's really about design. Whereas agile is about, well, quickly moving. Somebody said speed. I think that's a good word. Nimble, I think, is a very good word. Responsive, somebody said. Very good words to describe agile. And when I sit at home and play this game in the comfort of my office and think about which words should fit into both of these categories, and I came up with some of the same words as you, I think: incremental, iterative. Nobody said sprint. That's an obvious one, I guess, for the agile side. And on the other side, we have things like architects and constraints and qualities and structure and design. But down the middle, there's a whole set of words which apply, I think, equally well to both of these fields. And they are planning. There's a lot of planning in Agile. Might not be very long-term planning, but you have your planning meeting every couple of weeks, right? You do that if you're doing Scrum. Experience, I think, is very important in both fields. Nobody becomes a software architect straight out of school, do they? Everybody is promoted to be an architect. Nobody's ever just comes out of school and becomes an architect. I hope not, because experience is an important factor in software architecture. Experience is also a very important thing in Agile. You do your retrospective every 2 weeks, right? You're really good about your retrospectives. What are retrospectives about? They're about learning from experience. So experience is a very important thing. Requirements. That is the first word that should have come up from either side of the room. That is our job, is to understand requirements. Whether it's the requirements for architecture or what is a backlog? It's a list of requirements. Stakeholders. The Agile people, the Scrum people in particular, confuse this by talking about pigs and chickens, which I never really understood, but it's really a discussion about stakeholders. Whereas in software architecture, knowing who your stakeholders are and negotiating with them, because it is a negotiation, is a very, very important skill to have as a software architect. As a software architect, I think you need to spend a large amount of time and effort negotiating with stakeholders and moving people towards good outcomes for everybody. Validation is an important thing. We propose an architecture, but we need to be able to validate it. How do we know that that architecture is ever going to work? How can we do that? How do we do validation in Agile? We do TDD. We do testing at various levels. We do BDD. It's all about validation. And finally, the team. is something that's very common to these things. And we could say the team is just another stakeholder or set of stakeholders. That is true. But I think the team is worth singling out for special attention. So there is a significant overlap in what these two realms or these two approaches are concerned with. Planning, experience, requirements, stakeholders, validation, and the team. And we need to have good approaches to those things. And I don't see any reason why what is done in one realm should be necessarily incompatible with what we're going to do in the other, and that's what we're going to explore for the next 80 minutes. So what is the opposite of agile? Waterfall. Good man. Good man. It is waterfall, right? Or at least that's what everybody says, right? And I, with apologies to the gentleman in the front row, I would like to play my small part in dismantling this argument, right? Agile is not the opposite of waterfall, right? And in fact, I would argue whether waterfall ever existed or ever exists. So we're going to take a short detour now and look at waterfall. So this is the original waterfall paper. I'm not going to show you all of it, by Dr. Winston Royce. He was a doctor, he had a PhD, he must have known what he was talking about. And he wrote this paper called Managing the Development of Large Software Systems in 1970, right? And of course, the large software system in 1970 was quite a different animal to a large software system in 2013. But even so, given the techniques and technologies of the day, large then equates to large now. And he published this in the Proceedings of IEEE. And I encourage you to read this paper. This is what is commonly known as the Waterfall Paper. And fairly early on in this paper, on like page 3 or something, you run into this diagram. And nobody reads this paper past page 3, or so you would think from what people say about this paper. Because he sets out the well-known waterfall process. We do requirements, we do analysis, we design our program, we do coding, we do testing, and we ship it, and we're done, right? And that's the waterfall described, and that's what we all refer to as the opposite of agile, except that he said, do not do this, right? He said, do not do this. It doesn't work. Please continue reading the rest of the paper, right? The implementation described above is risky and invites failure, right? But the only thing people took from this paper is the actual diagram and ignored the important thing in the quote below it, which says, do not do this. This is a warning, not a manual. And it was 1970, right? The world of software was very different in 1970. Computers actually had buttons on them. You could become a well-paid programmer by reading a pamphlet. And advertising was more interesting. For modems, no less. Are modems sexy now? I don't think so. And if you do bother to read the rest of the paper, he has more diagrams. And look what he invented, or at least documented. He invented spike solutions, or documented spike solutions. He said, build it twice. Build it quickly once, here. Figure out what does and doesn't work, and then use what you learned from that to build the thing properly. Spike solutions, an XP thing. He invented iterative development processes. This is not the waterfall diagram in the middle. Look at the arrows, right? And it doesn't say you can only ever go back one, right? You can go back as far as you need to and as far forward as you need to. What did he invent in the top right diagram? He invented test-driven development. Look at the arrows. Testing goes to program design, which goes to coding, right? This is in 1970. Everything good was invented in the 1970s. TDD, and he actually practically invented DevOps as well, which is obviously operations integrated with testing and coding, right? So all of these things were in there. But the only thing anybody ever took from this paper was waterfall. And waterfall is a complete straw man. It doesn't exist. Nobody does it. I have never worked in an environment where people are doing waterfall like the waterfall diagram. They do not do it. The opposite to agile is this. It's just coding, right? I've worked in non-agile environments, and what people do is they don't sit down and make a huge pipeline of documentation and designs and things. They just sit down and they write code. That's all they do. This is the actual opposite. of Agile is just coding. Now, I just want to move on a little bit to design, because the Agilists, and I won't claim to be an Agilist in a kind of religious sense, the Agilists will claim that designs can emerge, and you don't need to do design as a large-scale process. If you do TDD, nice designs will emerge from your code, and they invariably use this picture from iStock Photos to illustrate their notion of emergent design. And I think this is true at a small local scale in your code, at the class level. I think you can end up with nice arrangements of classes, which are testable and loosely coupled and all the other nice things. But I do not think you get nice designs emerging at scale through the process of doing TDD. I don't think you can TDD your way from a large monolithic application to a nice service-oriented architecture, one step at a time. At some point, there's a disruptive break in that process, which requires you to do more than just write another test, have it fail, make it pass. All right? There's a mountain you need to get over. So I don't believe in emergent design as the only alternative to doing software architecture and taking design seriously. In fact, I think that Agile and architecture are complementary, orthogonal, independent, if you like, to some extent. I think you can be agile, and I think you can do architecture, and I think those things are entirely compatible if you think hard about how you do it. And the problem we all have is none of us think very hard about doing agile, or we just aren't very good at it, and none of us think very hard about doing software architecture and aren't very good at it. And so we either do a bit of agile and end up with very fragmented software, poor agile, or we do too much architecture, big design up front type approach, and end up with things that are over-designed, intricate, over-engineered, and cannot respond in an agile way when we need to be agile. My colleague this morning made a point about how it doesn't matter how agile your team is, your code base has to be amenable to being agile, right? You can go in with the best will in the world in the morning about how agile you want to be. But if your code doesn't allow you to be agile, you're stuffed. But I think there's a happy space here where we can have malleable, extensible, flexible designs which allow us to be agile. But I don't think we can get those just by doing TDD. I think we need to consciously design our systems with those qualities to allow us to be agile. So I think in the right hands, with the right approach, architecture actually facilitates agile rather than being in conflict to it. And as someone who's worked for product companies, I'm always very concerned with long-term sustainability of products. It's not just about shipping the next release necessarily. It's about still being here in 5 years' time, so your shareholders still like you. And it's interesting to think about the long-term or the effects of design on the long-term sustainability of your product. And really, I think a little design goes a very long way. Most people do essentially no design. And even if you just do a little bit of design, it doesn't need to be a huge investment. It doesn't need to be a 100-page document. You do a little bit of design, it will ease the path considerably. But of course, you can go too far and over-design things. Agile, I think, has a real problem. Who's worked in a place where you have difficulties with what's called agile adoption, right? Everybody wants to be agile. Everyone has good intentions, but it's really hard to make it work. And agile adoption is hard. And as a result, a lot of companies end up doing what I call nominal agile, right? They say they're agile, they're doing all the right things, but they are not actually agile. And I call this agileness. What is your level of agileness? Which is not the same thing as how agile are you? What is your agility? Right? Your agility is something I can observe about your system. Agileness is how hard you're trying at the process of doing agile. Right? And a lot of damage, I think, is caused by poor agile, because the first thing that gets thrown out of the window is software design. And all we're doing now is we're doing just coding again, but in iterations. And I think there's a lot of that going on. And then there's the fabled real agile. Hopefully we can get to that point where we have the malleable code that allows us to be nimble. And so you can think of these two curves orthogonally. You can tell I was once a scientist, right? And if you think of the kind of design curve goes like this, a little design helps a bit, going from left to right, then we reach a kind of plateau, and then too much design can be harmful. You know, analysis paralysis and all those good things from the 90s. Whereas on the other axis, we have agileness, where there's a dip first, where all we're doing is iterations, and we're not doing any design, because design doesn't really fit into the agile process. We're not thinking about quality attributes, because they don't fit into our backlog. Things get worse before they get better. And that is the cause of the agile adoption problem. And if you look at these things together as a kind of coherent space, there is a way from the origin of this chart here to get to the top where you want to be without going down the dip. And if you look at what way that is, you just look down on this thing. In agileness and design or architecture space, there is a way that avoids us going down the agile dip. And I would argue that the way to cross that chasm, if you like, is to do a little bit of design, or any design, frankly, to carry you across that situation. And if you look at the kind of initial vector that we're going off in the direction of doing design, primarily. And I think you need enough structure and enough design in your system to act as a counterbalance to the negative forces of doing nominal agile, which I think are significant. So, don't throw the baby out with the bathwater. When you start doing agile, don't just stop doing anything else you were doing that was good, right? I'm sure people are doing good design. You know, they stop doing it when they end up in an agile situation. Don't do that. Keep doing the good things. They're still good, even though you're doing agile. Who has read this book, The Goal? Right. I'd like you all to come back next year and say you have read this book, right? Because it's actually a management book. It's about a manufacturing business, right? That's what it's about. It's about optimizing production in a factory, right? What could be more different? And it's a wonderful, wonderful book. It's actually a novel, and it's very, very readable. And it's a bit of a page turner as well. But Eli Goldratt, who wrote this book, he has lots of really important messages about how to run a modern manufacturing business. And what he says is essentially reduce batch sizes, right? If your batch sizes are to manufacture 1 million things and something goes wrong, you've got 1 million duff components, right? Whereas if you produce things in small batches, then you get a much better flow of things through your system, whether it's a factory or whatever. And essentially, if you look at going back to the waterfall thing, design, or the iterative thing, design, code, test. I mean, the fundamental difference between this approach and what we do in TDD is only the time scale, right? TDD is design, code, and test with small batch sizes of one function or one test, right? Whereas traditional kind of approaches are design, code, test with large batch sizes, right? The reason Agile works is not because there's anything fundamentally different about it. It is small batch sizes. It is the theory of manufacturing optimization applied to software development. Reduce batch sizes, and there is less opportunity for things to go wrong. That's essentially what Agile is about and why it works when it does work. So the main difference is the cycle time, a year, a fortnight, or a minute. Okay? And we see all these things. Product cycles are years, sprint cycles are fortnights, and your TDD cycle is a minute or 2 or 5. Very short cycles. Ignore the horrible marketing on the cover of this book and just buy it and read it. It's wonderful. So there's our TDD cycle, which is just the same thing. The only difference is the time scale. So I would argue that Agile is a tactical activity, right? It's a response to conditions on the ground as we find them on the day, right? Because we know our requirements are going to change on a daily basis. And Agile is a tactical response to those things. And you don't go into battle with a formidable enemy having only tactics to hand. You have to have a strategy to win. You have to have a goal, a long-term goal in mind. And of course, all of your tactics can be compatible with taking you towards that longer-term goal. But you have to know what the longer-term goal is, and you have to know what shape the thing that you're aiming for is in order to get there. So really, I don't think Agile and architecture are any more incompatible than tactics and strategy are incompatible. Architecture, really, I think, is just strategic design. It's design on the timescale of more than 5 minutes, whereas TDD is design on the timescale of 5 minutes, with an occasional break of a few hours while you do some larger refactoring. So really, I think timescale is the fundamental difference between what we do or what we try to do as architects and what we try to do as developers doing Agile and TDD. Both of these things, in fact, the definition of strategy is a high-level plan to achieve one or more goals under conditions of uncertainty, right? And of course, that's one of the big selling points of Agile, is dealing with uncertainty. And I think if you build uncertainty as a requirement or a kind of meta requirement into your requirements, then you can design architectures which are able to accommodate that uncertainty, which will occur. You just don't know what it is because it's uncertain. So timescale, I think, is the fundamental difference. Agile is operating on minutes, hours, days, weeks. Architecture is operating on weeks, months, years. And they are no more incompatible as concepts than a clock and a calendar. We don't think of those as fundamentally incompatible things. It's really just about timescale. And there are many things we do in our daily lives where we need a calendar, not just a clock to plan them. And there are many things we do in our daily lives where a calendar is definitely the wrong tool. We need a clock to plan them. They're just different views at different timescales onto the same thing. So there is no cognitive dissonance between these ideas, I would argue. I think another issue that we face with architecture and Agile is something caused by an affliction in our industry, which is essentially fashion, I think, is an enormous problem in this industry. And lots of things are things that we have stopped doing just because they were cool, just because they're no longer cool because they were invented in the 70s, like all the good stuff, right? And we do stuff now because it was invented last week, right? The thing that's worst afflicted by this is JavaScript MVC frameworks, where as soon as you make a technology choice, it's obsolete, right? But I think other practices suffer from the same thing. Who here is familiar with the notion of the Gartner hype cycle? Lots of people, great. So the hype cycle is this notion that technologies in particular, but I would argue also practices, go through different phases, driven by the media. And the media in our case is, blogs that people write, the conferences that people go to. I'm doing media now, right? This is media in our industry. And what is fashionable is driven by these things. And essentially, we have an innovation at the beginning in a point called the innovation trigger. And the vertical axis on this chart is expectations. So something is invented. So the thing right at the beginning on the 2013 hype cycle is smart dust, right? I don't know what smart dust is. It's just been invented, right? It is not yet cool, right? But there it is, smart dust. You'll hear more of it soon. And you see quantum computing is near the bottom as well. And then we enter this period of the peak of inflated expectations where somebody like me stands up at the front of a conference hall like this and tells you which JavaScript framework you should be using for your MVC this week because whatever. And you all go and do that, right? And everybody's really happy because somebody has told them which framework they should be using, and they feel comfortable. Somebody's made a technology choice for them. Maybe they haven't had to think about it too hard. Maybe it is a little bit better than last week's framework. Maybe it isn't for their use case. So they go off and choose, and you enter this phase of the peak of inflated expectations. Right? Everybody expects this technology choice to change their world. But after time, you realize that your fabulous new JavaScript framework, well, it's still JavaScript, right? With all the limitations that go with that. And so we enter this period of the trough of disillusionment, where things just weren't all they were cracked up to be. And we're less happy with the decision we made. We're probably stuck with it now because there's this huge pile of legacy we've built around it, and we're going to be stuck with it for the next 20 years. But then over time, and at that point, many people leave the platform and go to the next JavaScript framework. And they do that actually by changing job, because they cannot change their code, so they change job. And we'll come back to this point shortly. Right? You laugh, because it's true. You know. I've done it as well. So we enter the trough of disillusionment. But the people who hang in there and stick around with this thing, eventually they learn how to use it. They learn what it's really good for. They learn when not to use it. And we enter this period of the slope of enlightenment, essentially, where we learn how to properly apply this technology and use it wisely. Wisdom, experience, these things are important. And eventually we become very good at using it and reach the plateau of productivity. And I would argue that both Agile and software architecture and any other practice you care to choose of in our fashion-led industry occupy a place on this curve. I don't think anything is really immune from this. And I've chosen to place Agile as just past the peak of inflated expectations. Would anyone put it anywhere else? Are people really disillusioned with Agile yet? Okay, Simon. Some people are, right? But most people have very high expectations that Agile is going to change their world and change the outcomes of their projects, right? But there are still just as many failing projects as there were previously, right? They just fail in new and exciting ways. Whereas software architecture, I hope is emerging from the trough of disillusionment. I think it is. I think we went through a very, very bad period, actually mostly just after the Agile thing came in, where we threw out all design, we threw out forward thinking, and all of that went away. Software architecture became incredibly uncool. Nobody wanted to be called a software architect anymore. Any kind of good characteristics of that went away. And software architecture was very, very uncool, right? And I'm saying this at a conference called Software Architect. But you guys obviously think it's cool. So I think it is emerging onto the slope of enlightenment. And I think we become good at doing the right amount of architecture and doing it intelligently and thinking hard about the value we get from performing software architecture as an activity, rather than just doing it. I think previously the backlash was caused by people doing architecture because they were an architect and that was their job, to do architecture. Right now I think architecture is becoming more goal-driven and we're more wise about how we expend resources on it versus all the other things we could be doing with that time. And of course, the problem here is, this is my name, there's just this gulf of cool between these two things. And I think this explains a lot of the tension between Agile practices and software architecture, is they're just at different times in their life cycle. And eventually they'll both be on the slope of enlightenment, and we'll be able to use them both quite happily. I don't know how far away that is. 5 years? 10? Probably at least 5. Yeah, I just wanted to throw in a few quotes at this point in the talk, which is that I've said that software architecture is strategic design. It's not design on your TDD timescale. It's design which is going to inform what are people doing 6 months from now or a year from now. And what TDD teaches us is that we should look at the results of our design, right? We should make design and we should see whether it works. And I think this is something that we do need to learn in architecture, because quite often architectures don't live up to expectations. And you do need to look at the results. Very good advice from Winston. He also had advice for the Agilists to get you through that initial dip on the curve, which is that if you're going through hell, keep going. Okay? Good timing. I'm going to move on to the next section of the talk now about sustainability and survival, and just keeping things up so that we don't only get to the end of this sprint and the end of the next sprint and the end of the next sprint, but we get to the end of something 100 sprints from now, right? And you don't care about this because you're all going to change jobs every few years, right? But people who own product companies do care about this because the 200th sprint is actually something that exists. It is there. It's not just a fiction. So how do you keep going for 200 sprints? And I think we need to achieve some sort of symbiosis between architecture and agile. They need not only to accommodate each other and learn to live together, but they actually can do good things for each other, like the clownfish and the sea anemone, right? The clownfish never ventures more than a few inches away from its sea anemone, and they live together. They perform a service for each other. And I think agile and architecture can provide good services for each other. Architecture can allow you to be agile. Most definitely. Okay. I'm going to pick on Scrum now, because, well, why not? Who's doing Scrum? Okay. I've done Scrum. Scrum is an incredibly simple thing, really, which is, I think, why people do it. And that simplicity can be a good thing. Or is usually a good thing. And as I said previously, it's about doing work in small batches, right? We have a daily cycle with our stand-up, when we report each day which batch we've just done, and which batch we're planning to do next out of our backlog. And then we have slightly larger batches of a few weeks where we get through a collection of backlog items. The backlog is just a very simple priority queue. And this results in work that is done. And you all know what a backlog is, right? It's just a list of stuff in order. It's a priority queue. And we take stuff from the product backlog and we feed it into our Scrum iterations. And I'm pretty sure you can't read this, because I can't read this, even though I can read it on here. The projection is not quite good enough here. But it's a priority queue. And these priority queues take many different forms, but they're all essentially the same thing. There are only so many ways of representing a priority queue. You might be using an Excel spreadsheet for this. That's fine. You might be using something like ScrumWorks, which is not fine. One of the great conundrums of Agile is, if Scrum is so great, why is ScrumWorks so bad? If Scrum delivers software like ScrumWorks, then there's something very deeply wrong with the whole thing. ScrumWorks again, you might be using Kanban on a Trello board or Post-it notes on your window or whatever you do. It's all essentially the same thing. It's a priority queue. There's the Post-its. And I just want to single out one particular backlog here for examination and highlight some of the words in it here. I'm going to read them to you because you probably can't read them. There's usability, disk space, usability again, everywhere is a good word. Performance, some, that's a plural. Automated tests, plural. And load stress tests, right? There are lots of things being crammed into this backlog which are not really features of the system, right? They are qualities of the system, things like performance, things like usability, or they are constraints on the system, things like disk space. They are not features, right? And the backlog structure of a priority queue is an extremely efficient and effective way of representing features that need to be done, right? Features are digital things, right? They are done or they are not done. You can represent the doneness of a feature in one bit, right? You cannot represent the performance of a system in one bit. It's an analog quantity, right? So we have all these analog qualities, and we have these kind of digital features. And the digital things work really nicely with Scrum or your favorite Agile process because they go into the system, and they either come back out again not done, or they come out the other end done, no problem. But all this other stuff goes into the system, like the constraints and the software quality attributes like performance and scalability and so on. And they're essentially analog quantities which cannot be adequately dealt with by the priority queue. And I've just shown you a whole set of backlogs, and they all show these characteristics of having people trying to cram things in that say, improve usability everywhere, right, as a backlog item, right? You know, good luck breaking that down into tasks that you can do in 2 weeks, right, because it's an enormous application that you're dealing with. But I've told you a lie, right? This is not a backlog in Scrum Works. This is a bug tracker, right? This is where these things end up, right? Because they don't fit into Scrum Works. What happens is they go into the system and they come back out as defects. So let's look at how that works. So we have some system here, the green rectangle. It's not important what it is. It's a software system. And we have an agile process that is very good at delivering features into that system on the short time scale you can measure on your clock, right? Hours, weeks. And as we pump features into that system and implement features in that system, various software quality attributes, and this is a software architecture conference, so I hope everybody knows what a software quality attribute is, those things emerge from the system, right? Whether you like it or not, the system you build, according to the features you implement, has certain performance characteristics. You can measure them, right? It has certain usability characteristics, if that's relevant to you, or scalability, or security, or all these other things. And these things tend to emerge from the system. And more often than not, they are not adequate for what we actually want the system to do, right? Because we couldn't fit them into our feature backlog to pump into the system with our Scrum process. But these things don't emerge overnight, right? They emerge on calendar timescale, right? And calendar timescale is software architecture timescale. These things emerge, and they come out as defects, right? And if we're really good, they go back as defects into the backlog. Quite often, they end up in a completely separate backlog in a bug tracker, which makes them difficult to prioritize. But because all of these things are cross-cutting concerns, each one comes out as 1,000 defects, right? And I think this is an important failure mode of a lot of agile processes, is that because we cannot fit the requirements, the non-functional requirements for software quality attributes into our backlog, we ignore them, we build the system, those qualities emerge, they're not up to snuff, they're not what we need, and then we translate those back into 1,000 defects, which we can then treat as features because they fit into our system. And of course, what software architecture is very much about is explicitly designing for these qualities and these constraints of the system up front or at the right time when you become aware that they are important. These things can change over time. And so software architecture not only needs to provide the context in which an agile process can deliver features, right? It's very hard to, in fact, not many of us need to start a project from scratch. Most of us are working on something that has already existed, right? And so what that means is that somebody has already done the fundamental architectural decision for you of building a system that has some sort of shape. Then mostly you are adjusting that system as you go. So software architecture at some point needs to provide the context. There are some important decisions that have to be made. Is this going to be on the JVM? Is it going to be native? Is it going to be on CLR? Is it going to be a web app? You know, someone has to decide that stuff. You can't TDD your way to that. Right? You have to start somewhere. And even if you don't call it that, that somewhere is their architectural decisions. Right? But the other thing software architecture needs to do is deliberately design for these constraints because you cannot fit them into your backlog. Right? You need to deliberately design for the constraints and for the qualities you want the system to have. Otherwise, you're just going to program yourself into a corner. I will put the slides on the web so you don't have to photograph them. So really, I think long-term software development is much more like gardening or farming as an analogy I like to use than it is construction. People are very fond of drawing analogies between software architecture and building architecture. I think software architecture is much more like farming in that it's about providing a productive context for people to grow corn or deliver features, right, than it is about constructing specific things. But as a software architect, I also think it's very, very important to get down and involved with the details of the system and avoid the perils of ivory tower architecture, where you think you know what's going on. You have to get involved and you have to do some coding. So really a model of sustainable development. And this is actually I like this because sustainable development, of course, we can apply that to us. We are developers, right? And we want to make sustainable products. But this is actually the definition for sustainable development that you would encounter in green circles, right? In environmental circles. But it's wonderful because the definition is just fantastic and entirely applicable to what we want to do. As architects, we want to provide for meeting ongoing needs, to meet ongoing requirements, whilst preserving the supporting environment. Whereas I would argue that a lot of naive agile or nominal agile actually meets ongoing needs at the expense of the supporting environment, which is non-sustainable development. I wish I knew who'd said this. I've been trying to track down the origins of this quote because I quite like it. And you have to think about this intelligently and not apply this naively, right? Because as an architect, of course, you do need to be interested in what your system is supposed to do and the features it's supposed to deliver. The point of this quote, which is you look after the quality attributes as the architect, and the features will look after themselves. What that means is there is no shortage of people in whatever your organization you're in thinking about the features, right? Most of the developers will be thinking about features most of the time. Your product owner will be thinking about features all of the time, right? And the business will probably be thinking about features, and the salespeople will be thinking about features and all those things. The one thing that falls through the cracks is the quality attributes. So I think as an architect, if you carefully apply this to your work and focus on the quality attributes, because everybody else is going to look after the features, and they're not going to look after the quality attributes. You look after the quality attributes, and the features will look after themselves. Right, this is a really long 90-minute talk, so I'm going to take a total excursion now for a few minutes, and we're going to talk about the nature of science, which is probably not what you came here for, but I have you captive here, and I'm going to talk to you about science. So I guess you're all familiar with the notion of the scientific method: formulate a hypothesis, perform an experiment, and collect data, and draw conclusions. Put another way, we make a prediction, we design carefully an experiment, we make some observations, and then we seek to explain those observations into some sort of model. And the reason I put this section in the talk is just to exercise and vent some of my own personal frustration about how we work as an industry, right? Because essentially we have very little knowledge in our industry of the efficacy of many of the practices we do, right? There's a lot of anecdotal evidence, right? And it's free to write a blog post and stick it up on the internet, right? There's a lot of anecdotal evidence about what we do, but there's very little actual hard evidence about how efficacious, which is a different thing from effectiveness, how efficacious many of the things we do are, right? So effectiveness is how effective you think something is, or how useful you think it is, and efficacious is how effective it actually is, right? And we have very little idea of how good many of these things are because we're very much fashion-led rather than science-led. And this is compounded by the fact that you cannot perform experiments on software developers in a controlled environment, right? I wish I could, but I can't. You wouldn't like it. Developers don't like to be watched by and large or monitored. It's almost impossible to eliminate extraneous factors to perform a good, well-designed experiment. People have tried to do experiments end up solving toy problems where you can write the code in 2 days or an afternoon, which don't in any way match the complexity or scale of the systems that we all deal with. No two projects are the same. That's a very obvious threat to validity. We can't do double-blind trials. You have to know what you're doing in order to do this. I can't feed you a pill without you knowing whether it's a sugar pill or something with some actual bioactive chemicals in it. And nobody wants to pay for this. In spite of the vast amount of money floating around in our industry, nobody actually wants to pay to find out how effective any of the techniques we use are. We're happy just to do whatever we do and live with the consequences. And so people say you cannot do science on software engineers or software engineering or developers or architecture or any of these things. And I disagree, right? Because the inability to perform experiments does not stop you doing science, right? It's also really difficult to experimentally collide galaxies, right? You cannot do this because, well, several reasons. One is you don't have anywhere big enough to do it. The other reason is nobody will pay for it, right? But this does not stop the science of astronomy progressing at all. A little bit of personal history. 2 British computer magazines from 1989, from my own history. I managed to dig these covers out from a now obsolete platform with which I had a lot of fun with when I was still at school. And these 2 magazines in particular, I think, are significant. These 2 issues are significant because they both deal with simulation of physical processes on your 1989 home computer, right? And one of them is colliding galaxies on the left, right? And I remember typing that program in, and it took a long, long time, and it didn't work. And the other one was simulating various earth science processes, building mountains and things. And actually, this issue of this magazine led to an entire career for me in oil and gas software. You know, from a schoolboy reading this, I then went on to essentially spend most of my career building software that does this properly rather than in a kind of type-in magazine issue. So the point is that you can do science on things where you cannot perform experiments, but you do it by simulation, right? You can simulate colliding galaxies, right? And you can see what the collisions look like, and then you can go out and look for those things in nature. So it's a slightly different scientific method, but it is still the scientific method. We make a prediction, we make a model, we design a model, and then run simulations. We then make observations of that model, what that model predicts will happen, and then we compare those with the real world. And we go around again and we adjust our model until our modeling results converge with reality, and then we can say, well, this model now tells us something about how the universe works. And you can do exactly the same with software. You can do science on software engineering. Okay, so that's the background. We can do science on software engineering. I hope I've convinced you. Now we're going to do some science on software engineering. So, how many people here have changed to a different project or a different company at any time within the last 32 years? Everybody's hand should be up, or nearly everybody's hand should be up. Keep your hands up. Okay. If that's still true for 16 years, keep your hand up. 8 years? Okay, good number of hands going down. 4 years? Okay, now we have about half the hands up. 2 years? Okay, now we have less than half the hands up. 1 year. Okay, 6 months. I'm going to stop now. Right? The half-life of a software developer in a company or on a project is 3.1 years. Right? This means that every 3.1 years, half the people on your project leave and go and do something else. Right? Usually because of what they've built. And it's true, isn't it? Right? We've all done it. Right? And it's interesting to compare the half-lives of various software-related entities, and I'm including you, the developers and architects in this room, as software-related entities, to other things, right? It takes 4.7 years for half of Windows XP users to upgrade to Windows 7. I guess they're upgrading to. No one's using Windows 8, are they? Applications, and this is a very broad definition of applications, includes line of business applications, have a lifetime of, or half of them will be replaced every 6.2 years. Okay? CEOs will be, of your company, is replaced fairly frequently. Half of CEOs change job every 6.8 years. So they move around less than we do. So think about who you blame for the fortunes of your company, right? Is it the developers or the CEO? Lines of code in code bases I've studied stick around for a really long time. You write a line of code and it isn't going to change significantly for a very long time. 13 years on one code base I worked on it takes to replace half the lines of code or change them, refactor them. FTSE 100 companies, I'm speaking in the UK, so that means something to you. Half of them changes every 22 years, the companies in the FTSE 100 index. Classes in systems I've worked on have a half-life of 37 years. That's enormous, right? It's very unusual for people to actually remove classes from a system. Systems accrete, they accumulate, they grow, and people write a lot more code than they delete. And as a result, the half-life of classes is very large. And if you go to larger units of code, modules or components or however you want to view this, module is a nicely generic term, they have an even longer half-life of nearly 60 years, right? Now, there aren't many software systems that have been around this long, but it doesn't mean you can't do the math to figure out what these things mean. Question at the back.
How does that compare to the other applications going after 6.2?
That's a really good question, and I think it's because code outlives applications, right? I mean, a lot of code is in libraries that is reused. A lot of applications are recycled into different things. So I think it's fine that code has a longer lifetime than applications. Okay, so I talked about simulation. And one of the ways we do simulation to deal with uncertainty is Monte Carlo simulation, which is where things are uncertain, we can run a very large number of simulations and get some idea of what's happening. And I think I've missed a slide here, right? But no, I haven't. It's coming next. What we can do is we can look at some data from studies which tell us something about the productivity of developers on a code base. And normally these studies will give you a minimum productivity. This is lines of code per year, right? So the least productive developer on a 10,000 line project is going to write 1,100 lines of code a year. Doesn't sound like very much. The most productive developer is going to write 11,800 lines of code a year. This is your fabled factor of 10, right? This is your 10x developer right there. But most developers, your average developer, is going to write a little bit more than the least productive, 1,250 lines of code a year. And you can use this to build a triangular probability distribution, and what we can then do is simulate populations of developers. So if I wanted to say, okay, what does the productivity of a team of 10 developers look like? I could make my cumulative frequency curve. I can go 10 equally spaced developers up here, and then we could get 10 developers out here. And we can see these yellow dots at the bottom of the developers. We can see that we have a lot of developers around the average productivity and very few highly productive developers. And looked at another way, software teams look like this, right? You have a couple of guys who are really good and a few people, most people around the median, right? And you may not like that because you're egalitarian and you believe that everybody should be equal, especially if you live in Scandinavia like I do, but that's just not how it works. That is not reality. Software teams have a distribution of ability and productivity. And you could argue that writing lines of code is not a good measure of productivity, and that's a fair criticism. But there we go. But the point is that you can simulate a software team. And of course, when they've written that code, their code is then bigger, so they have a different distribution. After you've written 11,000 lines of code on a 10,000 line project, you're now working on a 21,000 line product. So you move up this logarithmic scale. And you can simulate, what it allows you to do, in combination with the fact you told me earlier, which is that you change jobs every 3.1 years, right? You can simulate the evolution of a software team over a long time scale, and you can also simulate the size and other characteristics of the code they write. Okay, so here's a really simple simulation of a team of size 2 over 3 years, right? Really small product. You know, this is you and your mate writing something, right, and some small product. And we can see that in this simulation, those people wrote 54,000 lines of code over 3 years, right? But because they change jobs occasionally, this first guy, can you see this guy here? So the vertical axis here is code, is total code they've written at that point going crossways in time. So we start with no code at the beginning, and we have 2 people here, and the lower guy is really productive and he's writing loads of code. But then he leaves, right, the red line, and then his contribution is then constant for all eternity, right, because he's not there to write any more code, but his code is still there. But he is replaced by a new green dot coming in at the top, which is a new developer coming in, who is much less productive, right, according to the distribution, who then eventually leaves and is replaced. And what we see is that over the course of 3 years, we are going to get through 4 employees, right, 4 developers. So if you're designing a software system that you think can be built by 2 people in 3 years, actually you need to design a software system that can be built by 4 different people, 2 of which you have at any one time over 3 years, right? So I think when you're designing systems, you need to account for the total number of people who are going to be working on the system, not just the number of people working on that system at any instant, okay? Another interesting statistic is that when you get to the end here, only 60% of the code you have at the end was written by somebody who's still on your team, right? That means the other 40% you have nobody to talk to, right? And this is a really small project, right? Where are you going to go to find out about that code? And you were doing Scrum, right? So you didn't have any architecture documentation. You have nowhere to go to find out about that code except the code itself. So we can run these little simulations and we can have more interesting outcomes. Here's a 3-year project for a typical Scrum team of 7 people. We get through 11 people over that time period. Those numbers chime well with people's experience? Anybody working here on a team with, Scrum team, 7 developers, 3 years? How many colleagues have you been through? Probably, well, it'll be 11 plus or minus 2. We know that. And you will have produced 150,000 lines of code at the end of that. And 70% of that code will be written by somebody you can still talk to. But remember, we need to validate whether our galaxy collision actually matches up with reality in our simulation. So we can do that too. This is a simulation of a project I worked on, which was a product. It was a successful product. It was around for 20 years. We tend to recoil in horror at the idea of software that's 20 years old. You shouldn't. That software is successful because it's still there after 20 years, right? You should recoil in horror from the stuff that gets canned after 6 months. That's the stuff that has no value. So, team size of 20-ish, 21. We got through 114 developers in this simulation over that time period. And that matches up very well. I was lucky enough to be senior enough in the company where we did this to have access to records and go back and look through. You can also look through source control to get hold of these things, right, and see how many people actually contributed. And it is 114, plus or minus 9. So it's quite a narrow error bar as well. You're going to get through 110 people-ish, right? Think about designing a software system for 110 people to work on, right? Only 20 of which are there at any one time. That's a very different prospect from designing a software system that only has 20 people there, the same 20 people there all the time. And at the end, you're going to produce 1.8 million lines of code. In reality, we produced 2 million lines of code. That's pretty close. I would argue this is not a bad simulation of what we actually did. But the message I want to get over here is that you really need to think about the turnover in your product, in your project, as a constraint on how you organize things and how you build things and how much effort you put into documentation. Because people don't document things because they say, well, I can go and talk to him. Well, actually, you can't go and talk to him because he left 17 years ago, right? He might even be dead, right? I mean, it's true. I have worked with software developers who are now dead, right? I cannot go and talk to them. So, you need to factor these things into account. And you're probably not thinking about, well, 20 years is a really long time. But it isn't, because, we're really good at building software these days, and a lot of it will stick around for a very, very long time. I mean, who is working on something that's over 5 years old? Right, that's like nearly everybody. Over 10 years old? Still nearly everybody. Okay, over 20 years old? Okay, so, most of you are between 10 and 20 years, right? That's pretty old. So we can, well, this is 20 years. So at 10 years, 40% of your code is written by somebody who you now work with, right? That means 60% of your code is written by somebody you don't work with, right? So you can do science on software. But of course, you're not all working in the same corner of the system, right? It's not as if all of you are working with your colleagues in the same part of the system, and the 20% that is written on your team is all located in one part. So I really think that deliberate design, I think deliberate design is a good word for architecture, really, or software architecture. Deliberate design provides you with some context and structure into which you're going to produce the features you produce. And architecture gives a clear vision of how the system will work across entire generations of programmers. Because if you are successful, there are going to be generations of programmers. Right? And maybe you don't care about this because you know you're going to leave when it all goes bad. Right? But that's not a very professional attitude either, is it? That's not really why your employer is employing you. And perhaps if you behave responsibly with regard to these things, they might even pay you a little bit more. Yeah, so we're not all working in the same part of the system. Normally we are, the 20% who are remaining, or the 40% after 10 years, that's a better number for most of the people here. We're scattered throughout the system, we're feeling a bit lonely. It's disorienting, it's confusing, we have no context. And I think software architecture is a large part of the antidote to that. Right. Scaling Agile, bigger and better. I was going to call this section bigger and worse, actually. But I liked the alliteration of all the titles here, so I stuck with bigger and better. Does architecture have a role in scaling Agile? I love this quote. It was surfaced just a few weeks ago. If you can't feed a team with 2 pizzas, it's too large. Right? And I think this is essentially how we end up with 7 people in a team or 8 people in a team. Jeff Bezos from Amazon said this, and I think it's true. And other people have come up with similar number of 7 people. I couldn't find the exact quote. I think it was Churchill who wanted to have a cabinet that only had 7 people in it. He wanted an odd number so that he could have a casting vote. So that's an important thing, right? And he reckoned that 7 was about the right size. There was enough for diversity of opinion, but it wasn't large enough to break up into cliques of people who would go off and do completely different things in 2 or more camps. So 7 is a good number, and you can feed it with 2 pizzas. But I think what's interesting, we heard from Roy this morning about self-organizing teams and teams in different modes, survival mode, learning mode, etc., self-organizing mode. And I agree with all of that. I think it's all good stuff in the context of a team, right? But how many people are working here on a project that has a single team of 7 people? Right, okay, so both of you are here, right? And near the front. I mean, hardly anybody. I mean, we're all working on large things which need to be addressed by more than one agile team. right? And Scrum, actually, I'm going to come back to Scrum, but Scrum, for example, says almost nothing about how you need to make this work or what you should do. Well, actually, they have Scrum of Scrums, which is the dumbest idea ever, and I don't want to mention it. The idea that you can have a fractal management process that applies exactly the same techniques at every level in an organization, where the problems at the low level are very different from the problems at a high level, is just stupid. So please don't do Scrum of Scrums. I've been there, and it doesn't work. But the point is, irrespective of whether you're in kind of survival mode, command and control situation, as we have on one side here, or you have this beautiful self-organizing team, everybody's an architect, everybody knows what they're doing, everything's completely transparent. Irrespective of that, when you go beyond one team, the wheels really come off the wagon, right? I mean, I've been fortunate enough to work with some very, very good teams, right? It would be stretching it to say they were all perfectly self-organizing teams full of genius programmers, but they were pretty damn good, right? I had a lot of respect for them, and most of the teams worked very well most of the times. And what do they produce? This, right? Smartness is not an additive quantity, right? It is not. It doesn't scale up. And I think this is an enormous challenge, because most of the Agile community are focused on how do we get a really well-lubricated single team running. And you've just told me that that's an irrelevant question, really. That's not actually the problem we're trying to solve, right? You're all working in teams of tens or hundreds or maybe even thousands of people these days, right? Who's heard of Conway's Law? This is an architecture conference, come on. All hands should be up. Next year, you will all know about it, because I'm going to tell you. Right, so Conway, in a 1968 paper, How Do Committees Invent, gripping title, said that any organization that designs a system, and he used quite a broad definition of system, will produce a design whose structure is a copy of the organization's communication structure, right? And Eric Raymond reformulated this as saying, well, if you have 3 teams build a compiler, you end up with a 3-phase compiler. Whether a 3-phase compiler is the right thing, you'll have one team writing the lexer, one team writing the parser, one team writing the code generator, or however you do it, right? And this is absolutely true, right? I think this is the one thing that will be true about software development 1,000 years from now, or 1,000,000 years if we're still here and still care about developing software. It's absolutely true. For me, it's a kind of immutable law. And I've seen Conway's Law have both positive and negative effects, right? The only thing that, you just can't get away from it. People will produce things that mirror the structure of their organization, which is, when you think about it, means that it's probably a good idea if software architects have some influence over the structure of the organization that's going to build the code. They should at least be involved in those conversations. Otherwise, you end up with this disconnect between the shape of the organization and the shape of the thing you're trying to build. I love this cartoon. This is Conway's Law applied to some companies you may have heard of. I think it's just wonderful. I love the Microsoft one with the different, I guess this is Windows division and developer tools division, Xbox probably. Fantastic. I'll be sharing these later if you can't see them at the back. But it's absolutely true. And you're laughing because it's true, right? You know what kind of software these organizations build, right? You know that your login to Google Calendar has nothing whatsoever to do with your login to Gmail, right? Does it? It just doesn't work, right? So, whereas we know that, there's one guy, or was until fairly recently one guy at Apple who had his finger on everything. And it showed. So Conway's Law is true. I think you should just accept Conway's Law as a given, right? It's axiomatic in our industry. It is always going to be true. Don't even try to argue with it. Just, some things you just have to accept are true. I think if there's one thing you're going to accept is true, take Conway's law. But knowing this, you then have to say, well, okay, we can organize our agile teams, whether they, however good those agile teams are at what they do, we can organize those teams according to our software architecture and have teams building things that are congruent with the shape of the system we're building. But this doesn't answer the question of where does the architecture come from to enable you to do this. This architecture still has to come from somewhere. And what's more, the internal structure of these things still has to come from somewhere. And you might believe that the internal structure of these things is something that can emerge and be arrived at by TDD. But I would say that the large-scale structure of the systems will not emerge by TDD. Somebody has to sit down and actually design it somehow, right? And they might not design it all in one go, right? And when we have 1, 2, 3, 4, 5, 7 components here, right? They might design this in 7 steps, right? Over 7 years as the requirements change. But there is a deliberate design going on there. One of the problems I faced is, well, how do you organize this high-level design across multiple teams? Having worked in organizations with, 50 or 100 developers on multiple sites, how do you do this? And for me, this is an unanswered question. I'd be interested in your own thoughts after the talk. I've worked in environments where we've tried, so essentially we have some agile teams here adding features to a penknife representing lots of features. And we have a team of architects in the middle responsible for centralized design. I've worked in this environment. My experience with this environment is that it kind of works well for the design aspect. It tends towards the kind of ivory tower approach where you have this kind of secret committee of people who are throwing out designs for other people to work with. I don't think that's very healthy. But the biggest problem with this is it's impossible to defend this team of architects from other stakeholders of the system, right? Because what the other stakeholders see is a team of architects who are just pushing paper around and making boxes and arrows, right? Although that's not what they're doing, that's what they appear to be doing, right? And it's impossible to defend this team from other stakeholders of the system who will eventually be successful in turning it into a feature team. Much better, I think, to embed the architects in the projects, right? Maybe you achieve nirvana and you don't have a person who is the architect in a project, right? Maybe everybody is an architect. Maybe you can get there. If you can't get there, if you're in survival mode or whatever, then it's better to have somebody take, or multiple people, if you have enough people, take on that role and that responsibility in the project and have those people report not directly in a line management sense, but have them collaborate with other people in different parts of the system. And you know who they need to collaborate with because your large-scale architecture diagram tells you, right? Conway's law. There's a guy in the middle here, you might want a chief architect to run this process if you need that, to oil the wheels, to conduct negotiations on their behalf with management. That can help. Maybe not. But I think how to organize architecture in agile teams it's not a solved problem, but this model works much better, in my experience, than the centralized architecture team. Primarily because it's much easier for people in the teams to get buy-in from their teams to do the right thing. Yeah, so invest in deliberate design, invest in simple team-scale agile practices. I think, TDD, the XP practices in particular, very good, right? Just skip the quackery, right? The Scrum of Scrums, please, no, it doesn't work, don't do it. And there's no supporting evidence that it works. Somebody just said, oh, Scrum works with 7 people in the same room. Of course it'll work with 7 teams across 7 continents. No, it won't. Why would you even think that? I'm just going to finish now with one of my favorite recent tweets from Stefan Tilkov, which is, if you think there is a conflict between agile development and software architecture, you don't understand at least one of them. And I wholeheartedly support this view. They're both completely compatible things. Remember, they are the same thing. on different timescales, right? It's minutes versus weeks versus years. So I do hope we can get away from the Agile people trying to strangle the architecture people out of existence and just finish them off finally. I think we can get past that. Software architecture is on the slope of enlightenment. We are getting there. Maybe we'll be helped by Agile's plummet into the abyss over the next few years. I'm sure that will happen. The Gartner hype cycle tells us that will happen. I don't see any reason why it shouldn't. And I do believe that Agile and architecture can get along, right? And work productively together and be good friends and not have to get into a big fight about, oh, we can't do architecture because we're being agile, right? Or we can't be agile because we're doing architecture. Those statements are just not true. There's no evidence for that. So I think they're both really formidable characters. I think they both have a lot to offer. I think if we can get away from the zealotry and be more measured in our attitude to software architecture and to Agile, then we can both achieve a lot together. Thank you very much. Yeah.
In my case, we have outsourced development teams.
Right.
Who's developing components, and we have some internal development people also involved in
Yeah.
system. The outsourcing teams, because they're companies of their, they have their own goals and agendas.
Right.
And it's not feasible for us.
Put an architect into their company, right?
It's also not feasible to actually maybe mold one of them.
Yeah. I think I don't have an immediate answer for you. I've worked in similar situations where we've outsourced significant chunks of functionality or large components to other people, and the stuff that has come back, well, here we go. It generally has the right features, but it has completely inappropriate quality attributes, right? You know, it's not fast enough, or the usability is awful, or it doesn't integrate well with what else we have. I don't have the immediate answer. Obviously, you cannot put a person into that other company to do those things. I think where these things probably go wrong, though, is that you're not having conversations about quality attributes and constraints, the kind of conversations a software architect might have with that provider, right? You're maybe talking more about features.
Yeah, the point is that you can create very detailed specs.
I don't think you do have to create very detailed specs for a lot of these things. I think most of these things can be arrived at by actually having the conversation, right? And that's where my view of software architecture is that it's very much about talking to people about their requirements, particularly their non-functional requirements and what they actually want, not about spending time necessarily writing long specifications, right? Quite often, I think those conversations don't happen, and then the qualities emerge from those systems, and we have to live with them and fix them. It's very much about conversations. And I think the idea that software architecture is about producing large specifications for non-functional requirements is completely opposite to my view of it. Software architecture is about getting out there, talking to the stakeholders, the customers, the people who are buying your system, the people who are consuming the system, right, and talking to the people who need to build it for you, right? It's about conversation, very much. Next question.
So you had the diagram with the team of architects with this is the ivory tower architecture, and you said, okay, they'd make an architecture, but they couldn't defend it very easily. So you dispersed the team, put the architects in the product team. So maybe you got a more defensible architecture, but is it an equally good architecture?
Does it work well? I would say it can do, but only if you have the people there or the will for those teams to then communicate with each other. I think that's where that model tends to go off the rails, is you have inward-looking architects rather than outward-looking architects who are... I think if a team architect is only concerned with the internal structure of that system, rather than being primarily concerned with the requirements for that system from maybe just other teams in the same company, I think that's a very important part of that, to make that work. Yeah.
How quickly can the slides be available?
How quickly can the slides be available? Probably immediately after the talk if you come and see me. Otherwise, I'll get them up on the web this week. Yeah. I'll tweet about it, right? So if you follow me, you'll know about it. Yeah.
Given that agile teams often resemble a little of hyperactive puppies, how do you prevent them from ripping out the house while at the same time not just crushing that energy and enthusiasm, especially when you've got limited time with each team? There are lots of teams working in areas you've got architectural responsibility for.
I love a question without an agenda. It's how do you prevent them ripping up the house, the hyperactive puppies? Honestly, I think Roy said something similar this morning. Sometimes you need to slow down, right? And I think perhaps one of the objections of the hyperactive puppies is that software architecture makes you slow down, which is another way of saying it makes you think, right? And actually, that's a good thing. Going a little bit more slowly sometimes and taking the time to think. But to get that to work, you need to have an architect, or it doesn't have to be someone with architect on their business card, right? I'm using architect in the sense of somebody who cares about this kind of stuff, right? That's all an architect is, a de facto architect. Somebody who actually cares about these other things, other than features and iterations and all this stuff. You have to get those people in the team, I think. It's very difficult to influence these teams externally if you visit them once a week or have a telephone conference with them. And if you don't have those people in the teams, well, I would say you may well have those people in your teams already. You don't know who they are, because perhaps you haven't had conversations about software architecture with the people in the teams. So one way to do this is to find the people you already have. Even if it's someone in the team, they may not be an expert on these things, but they might be more interested in these things than the other people in the team, right? Find those people and coach them, train them, help them, support them to essentially push an architecture agenda within that team. Not because architecture is the be-all and end-all of everything, but because it's a good balance to the puppies tearing up the house. Yeah?
We've had the structure where we've had the architects in the centre.
Right.
And then we've also distributed architects out to the teams.
Yeah.
The issue that we've started to have is that the architects go native.
Right.
And they actually become just more experienced feature people.
Right.
And you get the stakeholders dominating the teams, and so then they're losing the battle about that.
Right. And this is something else I've tried to do in some Scrum situations, for example, Agile situations, is that the agenda gets very much driven by the product owner, right? Which is all about features, right? And I think if the product owner and whoever the architect is, the nominal architect in that team can get together on one side and talk about some of these other issues, the constraints, and not do that necessarily in the planning meeting, right? Do it out of band, go and do it somewhere else, and just have a good, honest discussion about some of these issues and try and push some of these things up the agenda. But ultimately, if your only means of getting things done is a backlog, I think you're probably stuffed, right? I think you are, right? I mean, the only question then is how long it will be before your software starts exhibiting the wrong qualities at the wrong levels, and you end up with thousands of bugs as the only means to fix them, right? Yeah.
With reference to co-location team structures,
Yeah.
first of all, how do you feel about spanning individual teams across both locations? How would you go about assigning roles within that?
Okay. My experience having done this is I would not split a team across two locations, right? I've been pretty clear about that. I think that's a mistake, right? I've worked in that situation, and I've never seen a good outcome, right? I've worked on teams which are on one site and seen bad outcomes, but sometimes I've also seen good outcomes. I've never seen that with a split team, really. It depends what you're doing. I think you need to identify the right people in those teams who share your agenda, right, who are closer to your agenda and coach them to advocate your cause, right? All of this is about people, right? Much less than it's about code. Projects do not fail because we can't figure out how to parse an XML file, right? They do not. Or even quite complex algorithms, we manage to build those things. Projects fail because people aren't talking to each other, or when they are talking to each other, they're talking to each other about the wrong things. So it's all about conversation. I have time for one more question if you're really quick. No, great. Okay, thank you very much.